This is it, the final roll of the dice, the last house call for one of the most important scientific instruments ever built. In May of 2009, Space Shuttle Atlantis blasted off on a mission of staggering complexity and risk, STS-125. Destination? The Hubble Space Telescope. The goal? To give our eye in the universe one last heroic upgrade. Before the Space Shuttle program, the only vehicle capable of such mission was retired for good. This was not just a repair mission. This was a high-stakes, all-or-nothing gamble to secure Hubble's future, and with it, our ability to gaze into the deepest, darkest corners of the cosmos. And let me tell you, it was anything but a walk in the park. For decades, the Hubble Space Telescope has been our window to the universe. It has rewritten textbooks, reshaped our understanding of the universe, and delivered images that have not only inspired a generation of scientists and engineers, but have become a part of our collective culture. By the late 2000s, however, our favorite space telescope was showing its age. Key systems were failing, and its instruments, once state-of-the-art, were being surpassed by newer technology. So how do you save a multi-billion-dollar national treasure when it's hurtling through space at 17,500 miles per hour? Well, you send in the A-Team. To understand why STS-125 was so critical, we need to rewind the clock. The idea for a large space telescope had been around since the 1940s, a dream of astronomers like Lyman Spitzer, who knew that to truly see the universe, we had to get above our planet's blurry atmosphere. After decades of planning and construction, the Hubble Space Telescope, named after the pioneering astronomer Edwin Hubble, was finally launched aboard the Space Shuttle Discovery in 1990. However, instead of the crystal clear images everyone expected, we got, well, this, a cosmic smudge. The telescope's main mirror, polished to near perfection, had a flaw. A tiny, almost insignificant error, just 1/50th the thickness of a human hair. But it was enough to cause what's called spherical aberration, making all of Hubble's images disappointingly fuzzy. The world's most expensive telescope was, for all intents and purposes, nearsighted. This was a huge embarrassment for NASA. However, Hubble had a secret weapon. It was designed to be serviced in situ by astronauts. And so, in 1993, the crew of STS-61 on the Space Shuttle Endeavour flew to the rescue. In a series of daring spacewalks, they installed corrective optics, essentially a pair of glasses for Hubble, and the blurry images were replaced with a stunning, sharp views we know and love today. This first servicing mission proved the concept. Hubble could be repaired and upgraded in orbit, and over the next decade, 3 more servicing missions would keep the telescope at the cutting edge of science. As the Space Shuttle program neared its end, everyone knew that the next servicing mission would likely be the last. The plan for STS-125, also known as Servicing Mission 4, was ambitious to say the least. Over the course of 5 grueling spacewalks, the 7-person crew of Atlantis would attempt some of the most complex on-orbit repairs ever conceived. The to-do list was long and daunting. First, 2 brand new state-of-the-art instruments needed to be installed. The Wide Field Camera 3, or WFC3, would give Hubble a new powerful eye, capable of seeing in a wider range of colors, from ultraviolet to near-infrared. This would allow it to peer deeper into the universe and capture even more stunning images. Then there was the Cosmic Origins Spectrograph. This was not about taking pretty pictures. The COS was designed to be the most sensitive ultraviolet spectrograph ever flown, allowing scientists to study the chemical composition of the vast empty spaces between stars and galaxies, and to understand how the building blocks of life are formed and distributed throughout the universe. Installing the new gear was, however, only half the battle. Two of Hubble's most powerful instruments, the Advanced Camera for Surveys and the Space Telescope Imaging Spectrograph, had failed and were never designed to be repaired in space. The astronauts would have to perform delicate open spacecraft surgery, removing dozens of tiny screws and replacing circuit boards, all while wearing bulky, pressurized spacesuits. On top of that, they needed to replace Hubble's batteries and all 6 of its gyroscopes, the spinning wheels that allow the telescope to point with incredible precision. They also planned to install new thermal blankets to protect the telescope from the harsh environment of space. And finally, they would attach a special soft capture mechanism to allow a future robotic spacecraft to safely deorbit Hubble at the end of its life. The crew of this historic mission was a mix of spaceflight veterans and rookies, led by Commander Scott Altman. Among them were seasoned spacewalkers like John Grunsfeld and Mike Massimino, who had both worked on Hubble before. Their experience would be crucial for what lay ahead. On May 13, 2009, after a 2-day chase, Atlantis and its crew finally caught up with Hubble. With expert precision, pilot Gregory C. Johnson maneuvered the shuttle to just a few feet away, and Megan MacArthur, operating the robotic arm, gently grabbed the telescope and placed it in the shuttle's payload bay. The real work was about to begin. The first spacewalk saw astronauts John Grunsfeld and Andrew Fustel tackle the installation of the new Wide-Field Camera 3. The old camera came out without a hitch, but as they tried to install the new one, they hit a snag. A stubborn bolt refused to engage. For what felt like an eternity, they struggled, with the clock ticking on their precious spacewalk time. Finally, with some clever thinking and a bit of brute force, the bolt gave way, and the new camera was securely in place. They also managed to replace the Science Instrument Command and Data Handling Unit, the very piece of equipment whose failure had delayed the mission in the first place. The second spacewalk of the mission was all about the basics: gyroscopes and batteries. Mike Massimino and Michael Good worked to replace all 6 gyros, which were housed in pairs. This was a physically demanding task, but it went smoothly. They also swapped out one of the telescope's aging battery modules, ensuring Hubble would have a steady power supply for years to come. Day 3 was perhaps the most challenging. Grunsfeld and Fustel were back outside to install the new Cosmic Origins spectrograph. To do that, they had to remove the old CoStar instrument, the eyeglasses that had fixed Hubble's vision back in 1992. With all of Hubble's new instruments having their own built-in corrections, CoStar was simply no longer needed. Then came the impossible task: repairing the Advanced Camera for Surveys. The astronauts had to remove 32 tiny screws to get to a failed electronics board. The tool they were using wasn't quite right, and for a tense few moments, it seemed like the repair might have to be abandoned. However, with guidance from the team on the ground, they improvised and successfully completed the repair, bringing the powerful camera back to life. Spacewalk number 4 was another nail-biter. Massimino and Good were tasked with repairing the Space Telescope Imaging Spectrograph. This involved removing an incredible 111 tiny screws. To make matters worse, a handrail was blocking their access. After much effort, Massimino, with authorization from ground control, used brute force to break the handrail off. It was a risky move, but it worked. They were able to complete the repair, and another of Hubble's key instruments was back online. For the 5th and final spacewalk, Grunsfeld and Fustel finished up the battery replacement, installed a new fine guidance sensor for pointing, and put on the new thermal blankets. After a grueling 36 hours and 56 minutes of spacewalks over 5 days, the work was done. On May 19th, 2009, with all the repairs and upgrades complete, Megan MacArthur once again used the robotic arm to release Hubble back into orbit. As Space Shuttle Atlantis slowly backed away, the crew took one last look at a telescope they had worked so hard to save. They had done it. They had given Hubble a new lease on life. The STS-125 mission was a resounding success. The newly installed and repaired instruments made Hubble more powerful than ever before. In the years since that final visit, Hubble has continued to make groundbreaking discoveries, from helping determine the age of the universe to studying the atmospheres of exoplanets. The mission was expected to extend Hubble's life until at least 2014. But here we are, over a decade and a half later, and it's still going strong. A testament to the skill and dedication of the STS-125 crew and the teams on the ground. But even with its new lease on life, Hubble won't last forever. So what's next? The future of space-based astronomy is already here, and it's even more incredible than we could have ever imagined. The James Webb Space Telescope, launched in 2021, is Hubble's successor, but not its replacement. While Hubble primarily sees the universe in visible and ultraviolet light, Webb is optimized for infrared light. This allows it to peer through the clouds of dust and gas to see the birth of stars and galaxies, and to look even further back in time to the very first light in the universe. Webb's mirror is also significantly larger than Hubble's, meaning it can collect more light and see fainter, more distant objects. Together, Hubble and Webb are a powerful duo, observing the universe across a wide range of wavelengths and giving us a more complete picture of the cosmos than ever before. And the future does not stop here. NASA's next great observatory, the Nancy Grace Roman Space Telescope, is scheduled to launch in the late 2020s. Roman will have the same size mirror as Hubble, but its field of view will be a staggering 100 to 200 times larger. This means it can map vast areas of the sky in a fraction of the time, helping us to unravel the mysteries of dark energy and to find thousands of new exoplanets. The story of STS-125 is a story of human ingenuity, courage, and our unyielding desire to explore and understand the universe around us. It was a final, triumphant chapter for the Space Shuttle program and the new beginning for the Hubble Space Telescope. And as we continue to push the boundaries of what's possible, we can look back at this incredible mission as a shining example of what we can achieve when we dare to reach for the stars. Thanks for watching. Like the video if you liked it, subscribe and ring the bell if you want to see more. I'll see you in the next one.